Okay, so at this time, I'm going to discuss simplifying complex rational expressions. Again, if we say complex rational expression, we are referring to a rational expression whose numerator or denominator or both contains fraction. Okay, so in short, a complex rational expression is a fraction of fractions. So for example, we have, okay, 1 all over 2/5. Okay, so notice that our denominator is a fraction, which is 2/5. The numerator is 1, and a denominator is a fraction, which is 2/5. If you notice also, there is a longer bar and a shorter bar here. The longer bar separates our numerator and denominator so that the numerator is the fraction or a number above the longer bar, and the denominator is the fraction or a number below the longer bar. Okay, another one is 1/3 all over 4, and again the longer bar is this one, and above the longer bar is 1/3, which is the numerator, and denominator is 4. Or we also have 1/3 all over 2 over 7. So both the numerator, which is 1/3, and denominator, which is 2/7, are fractions. So these are examples of complex rational expression. Or we also have 5x over 4 all over y, or x plus y over x minus y all over x minus y. So there are many examples of complex rational expressions that we know, but we only limit our examples into 5, so we can discuss some examples on how to simplify complex rational expression. Okay, so simplifying, we have, for example, we have simplify 4 plus 1/2 all over 3 over 2. Okay, so we have here 2. Again, our numerator is this one, 4 and 1/2, and our denominator is 3 over 2. So first of all, we have to simplify our numerator so we can simplify further our complex rational expression. So we have here, okay, the longer bar, okay, and we have our shorter bar here and our shorter bar here. So since our numerator is 4 plus 1/2, and then we recall the process on how to simplify fractions, or how to add or operate fractions. In this case, the denominator of 4 is 1, and the other one is 1/2. So in order for us to simplify or to add our fractions here, we have to look into their LCD, and the LCD must be 2, and the LCD is divided by 1 to be multiplied by 4, which is 8, and 2 divided by 2 is 1, times 1 is 1, and we just copy our denominator here, which is 3 over 2, and eventually we have 8 plus 1 is 9 all over 2 all over 3 over 2. And simplifying further, we have 9 over 2 Okay, so to simplify this one, to simplify this complex fraction here, we have to get the multiplicative inverse of 3 over 2, which is the divisor, and to be multiplied to the numerator, which is 9 over 2. So we have multiplication. The multiplicative inverse of 3 over 2 is 2/3. Okay, so that in multiplying fractions, we multiply the numerator by numerator, denominator by denominator. But in this case, we have to be very observant of our numbers or integers here in our fractions. Since 2 is divisible by itself, which is 2, and 9 can also be divisible by 3, which is 3 here, and this is 1, 1, and 1. So in that case, we multiply now 3 by 1 is 3, and 1 by 1 is 1. Therefore, the final answer is 3. Okay, the final answer is 3. So the simplest form of 4 plus 1/2 all over 3 over 2 is 3. That is our first example. Our second example is 3 over x minus 2 over y all over 4 over x plus y. Okay, so again, our numerator contains fraction and our denominator also contains fraction. So we simply simplify our numerator and our denominator so we can easily finalize our answer afterwards. So here we have our longer bar and our shorter bar in our numerator and shorter bar in our denominator. So in subtracting fractions or rational expression, again, especially if the fractions are dissimilar, then we have to get their LCD, and the LCD of x and y is xy. Okay, so xy divided by x here is y, times 3 is 3y, minus xy divided by y is x, times 2 is 2x. And we copy our denominator, 4 over x plus y. Okay, next, we simplify by getting again our multiplicative inverse of our denominator to be multiplied to our numerator. So we have 3y minus 2x all over xy times the multiplicative inverse of our denominator here would be x plus y all over 4. So we have x plus y over 4. Therefore, by multiplying, we have 3x times 3y times x would be 3xy. And 3y times y is 3y squared plus 3y squared. And then negative 2x times x is negative 2x squared. And negative 2x times y is negative 2xy all over 4 times xy. Okay, next. So let us observe the terms in our numerator. We have 3xy plus 3y squared minus 2x squared minus 2xy. So customarily, we put our variable x first before our y. So we have 2x squared, okay, followed by 3xy. So these are similar terms, 3xy and negative 2xy. So 3xy minus 2xy is positive xy. So we have here plus xy and then plus 3y squared all over 4xy. Okay? Is there something that we can do to simplify our numerator? Okay, none. So we have our final answer, which is negative 2x squared plus xy plus 3y squared all over 4xy. Okay, so that is our simplest answer to the given complex rational expression 3 over x minus 2 over y all over 4 over x plus y. Third example would be 1 over x plus 1 over y all over x minus y all over x plus y. Again, we have our numerator and denominator containing fractions. So we have our shorter bar, two shorter bars. 1 over x plus 1 over y are two dissimilar fractions. So take the LCD, which is xy. Xy divided by x is y times 1 is y. Plus xy divided by y is x times y times 1 is x. All over x minus y over x plus y. Again, the same process. We get the multiplicative inverse of the denominator, this one. And that is x plus y over x minus y to be multiplied to the numerator. So we have x plus y. Take note that y plus x can also be written as x plus y, okay, by commutative property, all over xy times x plus y over x minus y, okay? So simplifying further, we have x plus y times x plus y all over xy times x minus y. And therefore, we have x plus y times x plus y can also be written as the square of x plus y. So from here, we get x squared, square of binomial, plus 2xy plus y squared all over, okay, xy times x is x squared y, and xy times negative y is negative xy squared. Okay, so our final answer would be x squared plus 2xy plus y squared all over x squared y minus xy squared. Okay, so this is our final answer. So last example, we have example number 4. Okay, we have 1 plus 1 over 1 plus 1 over 1 plus 1 half. So first is we have to get rid of our fraction here. Okay, so we have to simplify. We just copy 1 plus 1 over 1 plus 1 over. Okay, so we have shorter bar, 2 in our denominator, times 1 is 2, plus 2 divided by 2 is 1, times 1 is 1. Okay, so we have 1 plus 1 over 1 plus 1 over 3 over 2. So we have now our fraction, which is 3 over 2, and 1 plus 1 over 1. Okay, so this is now our denominator, which is 3 over 2. So that is 1 times 2 over 3. So that is our fraction here. Okay, so again, simplifying further, we have 1 plus 1 over 1 plus 2/3. So we have 1 times 2/3 is 2/3. Okay, let us continue. So we have now equals 1 plus 1 all over. Okay, so we deal with this. So 1 plus 2/3 would be, this is over 3. 3 times 1 is 3 plus 2. That is 3 divided by 3 is 1 times 2 is 2. Therefore, we have 1 plus 1 over 3 plus 2 is 5 over 3. And therefore, we have 1 plus 3/5. 1 plus 3/5. So that simplifying our 1 plus 3/5 would be 5 plus 3 over 5. Or we have the final answer, which is 8 over 5. So the simplest form of the complex fraction, which is 1 plus 1 over 1 plus 1 plus 1/2, is 8 over 5. 8 over 5. Okay? So we have 8 over 5. That is our simplest form of the given complex fraction. Okay, so please don't forget to subscribe into my videos, and you may also share so that others may learn like you. Thank you very much.